All right, guys, should be the recording for 8th grade math, and today we're looking at lesson 40 again. Kind of, I don't want to say speeding through these, but hitting these lessons and kind of doing them in a review form, so that way we get through a lot of it in a short amount of time. Hopefully, what have we covered? Decimal place. We've done a lot of vocab. Repeating decimals, percentages, multi-step equations, and things like that are hopefully reviewed, so we can kind of hit this and relearn it and re-solidify it, and then move on to some more complicated work. So we're going to look at lesson 40. Go ahead and share here. I'm going to turn myself off. Okay, so let's get to jumping ahead. Okay, this is going to be on page 264. So we're looking at area of a circle. Again, this is area formula. It should be on your reference sheet. Let me make sure we're still recording and sharing. I'm getting bumped off occasionally, so. All right, so I think they use this example or kind of this illustration last year in the book, but I do like it because if we look at a circle and we do a square around it, well, the square is going to be a little bit larger than the circle, but then if we did a square within a circle, obviously it would not be big enough. So we need to have an area formula, and that's where we come up with this. So we have radius and radius. That creates a square here, here, and here. So again, radius times radius is radius squared. But if we did 4 of those, 4r squared, that would be too great. But if we just did 3 of them, 3r squared would be a little too low for our area. So that's where we come up with people a lot smarter than me a long time ago that apparently didn't have anything else to do. They compared the ratio between circumference and area of a circle and then its radius, and they kept coming back with this constant that was eventually they early on estimated around 3, and then it came 22/7 and 3.14, but it is now just used in this symbol, and we call it pi. So if you ever see this symbol, that's referring to a number. It's just an irrational number that has a decimal that goes on forever. So in formulas and stuff, instead of writing it out to 10, 20, 30, 40, however many decimal places, we just use that symbol. And we have that on our calculator. There's a button for pi. Commonly, we'll use either 22/7, 22/7 as an improper fraction, or 3.14. Those are both rounded versions of the number, so not perfect. But again, we don't want to take it out to 100 or 1,000 decimal places. There's people that have taken it out to several thousand. They have computer programs that's taken it out to a million decimal places. I guess that's interesting, but sounds like a lot of time that I don't want to devote to it. So that is pi. So our area formula for a circle is pi times r squared. So really all we need to know is the radius. We square it and then we multiply it by pi, and we have it. So let's look at example 1. A circular table has a diameter of 6 feet, so that means the radius is 3. So again, don't get moving so fast that you forget to distinguish between diameter and radius. Radius is half of the diameter. So if we're given 1, we can easily find the other. If 4 students sit around the table, then each student should be about how many square feet of work area? Okay, so we're going to find our area of the entire table, the circular table, so pi r squared. Our diameter was 6, so our radius is 3. 3 squared is 9, so that's where we get that. And then we multiply it. This symbol right there means about. Since we're not using an equal sign, it doesn't equal 3.14. It equals about 3.14. We multiply that out, we get 28.26. Okay, and then we divide that by 4, so they all have equal workspace, and it's about 28 divided by 4, so it becomes about 7 square feet. And since it goes on forever, we're going to have to round off at some point. So 2 decimal places is commonly where we round it off to. Sometimes we'll be told to use 3.14, 22/7. Other times we'll be given circular problems and asked to leave it in terms of pi, which just saves us one step, which is great. So the circumference of the circle, remember, circumference of a circle is 2 pi r, or pi times the diameter. 2 radius would be 6 times 2 is 12, times pi, we would just call it 12 pi. The area of the circle, well, radius squared, 6 squared is 36 times pi, we would call it 36 pi, and then inches squared. Don't just call it 36 or 36 inches squared, it's 36 pi, 36 times pi, but we can just leave it like that, 36 times pi, and then inches squared. Don't forget your units, it's still square inches because we're talking about area. For circumference, similar to perimeter, it's just one-dimensional, so it's just inches or feet or centimeters or whatever. Some new terms, we have a sector. The sector of a circle is a portion of the interior of a circle enclosed by 2 radii, so from the center to the side, plural for radius, and an arc, a portion of the circle along the outside. That is our sector. If you've ever thrown discus or shot put or something like that, or you have a certain landing zone, they'll call that the sector because you have a radius, a vertex point, and then 2 equal distances, and then the area within that. The angle formed by the radii, so this angle right here formed by our 2 radii, radiuses, either way it sounds weird, called a central angle, determines a fraction of the area of the circle. So we know an entire circle is 360 degrees. So let's say we have a lawn sprinkler waters a circular portion of a yard. The radius of the circular portion is 7 feet. Calculate the area of the yard watered by the sprinkler. Okay. I have to use 22/7 for pi. Well, our r squared. Let's draw. Okay. So it always helps to draw out or write down what you have. So our radius was 7 feet. And we're going to use, not 3.14, we're going to use 22/7 for our pi. Okay, so pi, or 22/7 r squared, 7 squared, which is 49. And it was feet, so we're still working at square feet. I know 7 goes into 7 once and into 49 7 times because we just squared it. So 22 times 7, that comes out to be 154. So this is 154 square feet. So in this example, it made more sense to use 22/7, which they told us to do, which usually the book or the test tells you to use the one that's going to make the problem a little bit neater. So we were able to cancel out 7 in the denominator and up here, so it came out to be a whole number, 154 square feet. Again, we use these symbols to indicate it's about, not technically, but for our sake of knowing how much water we're using and all that, that would be close enough. What effect does doubling the diameter of a circle have on the area of a circle? Well, this goes back to scale factor we talked about. So if we're talking about area and we double or multiply it by 2, that's actually going to affect the area 4 times because it's 2 squared. So you can think about, and this is true of any polygon or any 2-dimensional shape that we have. So let's say our diameter was, well, let's say the radius is 1, diameter is 2. So diameter 2 is radius is 1. So we would do pi r squared, pi times 1 squared, so it'd just be 1 squared is 1, so it'd just be 1 pi, or pi. And if we double that, And we now make the, let's pretend that goes through the center. We make that 4, and the radius 2, well, now 2 for a radius, 2 squared times pi, 2 squared is 4, so it becomes 4 pi. So it's 4 times greater than the original. So making the dimensions 2 times bigger, 2 squared is 4, so the area is going to become 4 times bigger. And when we get down the road and talk about volume, it's a scale factor to the power of 3. So if it's perimeter, anything that's one-dimensional, it's just a scale factor to the power of 1, or just a scale factor. If we're talking about area, 2 dimensions, then we square it. Volume, 3 dimensions, then we do the power of 3, or we cube it. So it's trying to boot me out of my own recording. Sorry. All right, the area of the sector, well, 45. So 45, we know 360 is the entire entire degrees that make up a circle. So 45, we could do 45 divided by 360, or we know 45 plus 45 is 90. So there's 4 of 90, so there'd be 8 of these 45-degree sectors in a circle. So we can find the area, reducing it down to 1/8. The area would be, and we want to leave it in terms of pi, so the radius is 4. So 4 squared is 16, so 16 pi centimeters squared times 1/8. Okay, 1/8. The radius was 4. Well, pi r squared, that's 16 pi, and then we know 45 is 1/8 of our circle, so 1/8 times 16 comes 2 pi, and what were the units? Centimeter, 2 pi centimeters squared. So if we know the area of the entire thing, which is just pi r squared, and then we know the portion of the sector, in this case it was 1/8 of the entire circle, just do the area times 1/8, and that tells us the area of this region in here. Okay, then we get to our practice set. We will do that as a class. So if you want to go over it or look it over, that's fine, but we will go over these in class. And just some review of circles. Most of those should be on your reference sheet for circumference and area of a circle. You may have it memorized. But, keep moving along, come into Math Lab if you guys have questions, and keep up the good work. Thanks.